Now, just note for the interactive question here, following the order of operations, 3x squared is really 3 times x squared with a breath there, since exponents happen before multiplication in the order of operations. So here's your interactive question. Using xy charts, I would like you to graph y equals x squared and graph y equals 3x squared. So you've got to use those xy charts here. I want you to really discover the pattern. So pick, I would say, it would be helpful if for both of these you pick x equals -3, -2, -1, 0, 1, 2, and 3 for both of these. Okay, based off of your xy charts, you should graph y equals x squared and y equals 3x squared. Then, as a separate thing, using xy charts again, graph y equals x squared and graph y equals -x squared. Again, note that exponent happens and then the minus happens after. So please try this on your own. I think what's going to be best for this is to really draw pictures and turn that in. And then, after that, even though it's not part of the interactive question is just to do the task. It is important that you try the task. But then after the task is done, let's take a look at what's going on. Right? So let's take a look at a picture of y equals x squared and compare that to a picture of y equals c times x squared. So it looks like this. So y equals x squared is shown here in black. Y equals cx squared is shown in red, but c is equal to 1 currently by default, so the two graphs overlap. But if we change the value of c, now I know this looks like it's pushing inward, but what's actually going on is right here the graph is stretching up vertically. And then if we change the value of c to be negative, like let's just see even -1, looks like this, and then that has no stretch, it has just been flipped. But if we pick c equal to -2, then it's like down here where my mouse is currently, if we just stretch this by pulling from here, grab and then pull downward like that. Okay, so we'll just see what that looks like for different values of c here. Of course, you can experiment with this on your own because a link is provided. So here's the question. If c is positive, what do you do to the graph of y equals f of x to get the graph of y equals c times f of x? What you do is you vertically stretch by a factor of c. Now, if c is negative, what do you do to the graph of y equals f of x to get the graph of y equals c times f of x? Now here c is negative. So imagine like, -3 times f of x. Then you should vertically stretch still by a factor of c, or I guess technically absolute value of c because c was negative. But you also need to flip the picture vertically when you do so. And we kind of saw that occur here, yeah, with c being negative, the picture always seems to be upside down in red. What you see is upside down there. So, how do we graph f of x equals 45 times absolute value of x? Well, there's y equals absolute value of x. And then if we stretch this vertically by a factor of 45, instead of being so shallow for the slope, it's going to be much sharper. And it's going to, this piece here is going to end up being like right there instead. So we'll have something that looks like this. Y equals 45 times absolute value of x. Here's another. How about f of x equals negative absolute value of x. So there's y equals absolute value of x, and then the negative sign just flips vertically, and here's a graph of y equals negative absolute value of x.